I'm just wondering how many males and females are left in the finals here. So let's see, that's 901 and 435. Let's see. 901. Oh, that's about the Cubs. No. I need to know 901 themselves. There's 901 right there. 901 is a female. Yep. 901's a female. And let's see, who was the other one? I already forgot.
It was Holly.
Was it Holly?
Mhm.
435. Yeah, 435. And that's a female. Chunk's the only male bear. All the big ones are girls this year. So, yep. 3 females and Chunk left in the finals. So, cool. All right. Well, enough of that good stuff. Down here, let's look at our actual. Let's see. I don't need to be in the algebra. I need to be in computer and network security fundamentals. All right. The OSI. This is a little bit more complicated this week. I've looked through this lesson. There's a lot of terminology and things to keep straight. So, on the assignment, let me go to the assignment. I've given you 3 attempts on there, which I've tried to do that more often. But since this has a lot of terminology, it's easy to get confused if you're not keeping it all straight. So if you don't do well the first time, go back and see the ones you missed, do it better. But let's look at this. This is a lot of technical terms this week. So we'll look at the OSI model. So when networks function, there's a lot going on behind the scenes that you don't even see. So OSI is the Open Systems Interconnection. Open Systems Interconnection model. This is the theoretical representation of how a network operates. So this allows network professionals to understand what's going on in the background. So let me change how I'm sharing this because there's a video that has some sound to it. If I don't share it properly, you won't be able to hear anything. So let's look at the OSI layers.
Let's talk about layers. For pizza, it's the crust, the sauce, the toppings, layered together in a perfect package. IT professionals use layers when referring to the Open Systems Interconnection, or OSI model. This model visualizes a networking system in 7 layers. Think of the layers like the steps you take when ordering a pizza. In this case, pizza equals data. Layer 7 is application. This is where a customer picks up the phone to place an order. In OSI, it's what the user sees and interacts with. Next is the presentation layer. The order is translated into something a chef understands. A large pizza with sausage and olives may be translated into special number 6 on your check. Then the order is confirmed. This layer, session, is all about two-way communication. Without someone taking the order, your pizza dreams would end here. Layer 4 is called transport, but it's all about quality control. In this step, your pizza is checked for accuracy and quality before it leaves the kitchen. In the network layer, data, or in this case, pizza, is delivered using the best route. Layer 2, data link, provides a physical address for delivery. Like pizza, data needs a specific location, otherwise it could end up lost. Finally, in layer 1, the physical delivery happens. Unlike ordering pizza, OSI works both ways. Data can travel from layer 7 to 1 and back again. So, what's the point of OSI? If your pizza isn't right, the manager will follow the steps in your order to see where it went wrong. OSI is like those steps. It provides a point of reference that lets network managers and programmers troubleshoot. Your job is to get familiar with the layers, learn what they mean and how they connect.
So yeah, we got all this terminology. There's 7 layers and stuff in there. I'm not going to run that again, but thing I noticed in there is I don't even think they cut that pizza. They put it in the box without cutting it, was closing it, and then somehow it was magically cut when they got to the customer. That's just pickiness. All right, let's go on. So here are the 7 layers: application, presentation, session, transport, network, data link, and physical. So let's look at those 7 layers because, like I say, this is a lot of terminology this week. So we start with the application. That's what the user sees, right? Applications that work at layer 7 are the ones that users interact with, like web browsers, other apps like that. They provide the protocols, which is the formal standards and policies that made up of rules, procedures, and formats that define communication between 2 or more devices of a network. So they provide the protocols and services that are required by the apps to connect with the network. And here's examples like the www browsers, the FTP. You may see these terminology, POP3, SMTP. A lot of times when you're trying to set up a new email program on your computer, you'll have to enter the SMTP and all that kind of stuff so it knows how to connect and get your emails. Layer 6, presentation. So the presentation layer translates data from the network to the application or vice versa, right? So that's like ASCII, BMP, GIF, JPEG, WAV. It's like, we see a JPEG and we open it up and we can see the picture, but that's encryption. That's taking all the data, encrypting it to where they can send it over the network. And then we open it on the other end where your computer takes all that data and translates it back into a picture. So an example is the encryption of data for secure transmission. All right, the session. When 2 devices like a computer and a server need to communicate with each other, a session needs to be created, right? So like web conferencing, which streams the audio and video, it's got to be synchronous so the speaker's lips match what they're saying. So examples of that is NFS, NetBIOS names, RPC, SQLs, a lot of technical stuff in here. Layer 4, transport. The transport layer handles the coordination of the data transfer between the systems, the end systems, and the host. How much data to send? At what rate is it sent? Where is it being sent to? So the best example of the transport layer is the transmission control, the TCP, which is built into the Internet Protocol, the IP. So you'll see this terminology sometimes. You get it digging into settings a lot of times. You'll see TCP IP. That's the Transmission Control Protocol. And we're not going to get real deep into how all of this works, but just understanding that it exists and kind of an idea of what it does. So the network, layer 3. This layer provides switching and routing technologies, creating logical paths known as virtual circuits for transmitting data from node to node. It's basically setting out the route. Routing and forwarding are functions of this layer. So you may AppleTalk, DVP, IP, IPX, the layer. So the IP address, all that good stuff. The data link. The data link is where the node to node transfer occurs and where most switches operate. It has 2 sublayers, the MAC and LLC. You see, MAC is the sublayer of the data layer in the OSI model that defines how the data packets are placed in the media. Provides physical addressing. LLC is the sublayer that identifies the network layer. And here's examples of terminology you may see that refers to data links. PVP, FDDI, ATM, the IEE numbers, different numbers for that, HDLC, frame relay. And finally, the physical layer. This represents the electrical and physical representation of the system, like cable types, radio frequencies, like those used in Wi-Fi, voltages, other physical requirements. So network professionals will typically check this layer first when there's an issue. Is there a problem physically with the 10 base T, the 10 base 100, these type of things down here? So here's an illustration of how data would move from a sender in system 1 to a receiver in system 2. All right, so you got all of these different layers. builds the application presentation. So it goes from one to another layer, and then it goes down here and actually transmit it. And it kind of go in the opposite direction, comes in through the physical, then it's all the way back to where it's translated back to where your application, back to what you see on the screen. Starts with what you see on the screen and on system one, and it goes through all of the network systems to be able to transmit it over to the other computer where it's reversed over there to where it gets back to what you see on the screen. You see the layers build up where there's more and more data being transmitted because it has to do all of this work to get it ready to transmit to where, again, you just see what's on the screen. All right, let's see what else we're going to throw at us. The PDNTSPA. What? That is the first initials. If we go back here, starting at the bottom, PDNTSPA. They're trying to give you ways to remember those 7 terms. So here's what they suggest. Please do not throw sausage pizza away. Start at the bottom. P, please do not throw sausage pizza away. There's some better ones. There's some better ones down below here. Depending on whether you want to learn it from the top to the bottom or the bottom to the top. See, I kind of prefer Pete doesn't need to sell pickles anymore. I kind of like that one. This one's good too. A penguin said that nobody delivers pizza. But who's listening to a penguin? What does he know? All pros search top-notch donut places. All people seem to need data processing. Just something to help you remember the acronym PDNTSPA, or backwards APSTNDP. So, well, whatever you like. Whew, dead Ninja Turtles smell particularly awful. Well, that's probably true. Yeah, dead Ninja Turtle. But yeah. Anyway, pick something you like. Just try to help you remember those terms, or just write them down in your notes where you got them all. But yeah, different ways to help remember those. So what is a protocol? We keep using this word protocol. A protocol is a set of rules that governs the communications between computers, right? For 2 computers to talk to each other, they got to be speaking the same language. So many different types of network protocols and standards are required. I mean, protocols are rules. A set of rules. There's protocols outside of computing. You know, to do things, there are certain protocols that you have to follow, which is the rules that govern things. So no matter which operating system, network card, or application you're using, you still got to make sure your computer can communicate with another computer because it may be running a different system. We can have Windows computers talk to Apple computers because they use these same network protocols to convert things where they understand each other. So this has those same examples we saw on the other page. It has them all summarized in one table here. For the application layer, SMTP. The session layer would be the NFS or the SQL or zip file. Zip file could be a session layer. Network layer, the routers, the layer 3 switches, all that stuff. Bluetooth, Ethernet, those are all examples of the physical layer. Wi-Fi. So the OSI model is filled with several networking protocols. So review your understanding of the OSI model and different protocols below. So here's a way to kind of practice and see what you understand. Read the question, select the best answer. Layer 6 of the OSI model is also referred to as what? Session, application, presentation, transport. Well, if we go from top to bottom, let's see, the layers numbered from the top to the bottom or the bottom to the top? Top to the bottom. So presentation, yeah. So a penguin, right? A penguin says nobody gets pizza delivery, whatever. So presentation, nice job. All right. So what's the next one? Which layer assumes responsibility for managing network connections between applications? Well, is it actually network, you think? Let's try network. No, missed that. Managing network connection between applications. Maybe it's the application network. See, I haven't learned these very well either, guys. So. Let's see. back to our quiz that we've working on. Layer 6, we said that was presentation. Managing network connections between applications. Guys, got any thoughts on that session? You think session? Perfect. You're on top of it. Media access control and logical link control. MAC and LLC. That was two of those abbreviations they gave us. They are sublayers of the components of which one? Which one was MAC and LLC? I think it's data link. All right, fabulous. Which layer is responsible for breaking up data into segments? Segments. Transport. Yep. All right, I'll leave the rest of those. We don't have to go all those together, but good job. Do you understand those? Employability skills. One of the most sought after skills in computer networking is the ability to talk about technical information, right? Network professionals communicate well, have an advantage in building their careers. Job interviews are a place where you'll need good communication skills. Being able to have a relaxed conversation with people about technical subjects can be hard to do, but with practice, a person can handle even unrehearsed questions well. So practice communication skills by visiting job fairs and discussing professional subjects with friends. So that's good advice right there. All right, let's look at page 5. What are data packets? So when you send an email or read a news story on your phone or you shop online, you're sending in and receiving information digitally, right? It might look like you're sending a whole photo of your new puppy to Aunt Sue across the state, but it's actually just a collection of electronic data broken into tiny pieces. This is all made possible by using something called packets. Turns out everything you do on the internet involves packets. On the internet, the network breaks an email message into smaller parts called bytes, right? It breaks it down to bytes, and they are the packets. These smaller parts are the packets. So each packet carries information that helps the message reach its destination, which is your IP address, sender's IP address, right? Numbers put separated by periods that identifies each computer to communicate over a network. The intended receiver's IP address, something that tells the network how many package this email message has been broken into, and the number of this particular packet. So it's breaking it down. So it's sending multiple packets, but it's also sending something that tells the receiving computer how many packets to expect, right? And then the packet carry the data in the protocols of either TCP/IP, the protocols the internet uses. So it travels in packets over digital networks, and all the data, whether it's text, audio, images, video, comes broken down in packets that are reassembled on the other end. So it's easier to break it down into small pieces and send it on the network than to try to get a big piece into there. Think of it as trying to merge in the traffic. If you're a semi, it's harder to merge in the traffic than a little bitty car. So that's kind of how they're doing this on the internet, is it breaks it down in little pieces and it's easier to get it sent to the network. So TCP data packet would look like this. A header. Every packet has a header which tells the router where the data packet needs to go. It lets the recipients know where it came from and the order for putting it back together. Because if it breaks it up in pieces, it needs to know how to put it back together on the other end. Which piece goes first, right? So it'll get information like this. Here's the destination IP address. There's the sender, where it came from. And this is the number. This is the first packet. Then the payload. This contains the data that's being sent. Whether it's your email, it's a picture, it's a video, whatever. It'll have all of that data right there. And then this is a checksum value. This is a value that's used to verify the correct transmission of the data packet for error control, because things can get messed up. So it's checking that it has the right checksum data to verify it was transmitted correctly. It wasn't corrupted during transport. All that's going on just when you send an email. for many, many packets, not just one packet. It's got many packets it's broken up into. So let's follow a data packet as it's sent from a sender to a recipient. So data is created by an application, like a document created with word processing, right? So this is the application layer. That's what we actually see and interact with. Then data is split into packets by TCP, and everyone's given a sequence number. Here's the first packet, second packet, third packet, fourth packet. And this happens at the transport layer. Getting ready for transport, getting ready to send it. I'm going to break it up and number it. IP adds destination sender IP addresses to the packet at the network layer. The network layer says, okay, here's the IP addresses of where you want to send this and where it's coming from. So then the IP address packets are encapsulated into an Ethernet frame that includes the MAC address of the router. Right? So it goes to the router, sends the MAC address of what other router is looking for. Each frame is then passed to the local access network's router by the switch, and this will all happen at the network layer as well. So it comes from this computer to this network, to this local area network, and getting ready to send it on. So the router inspects every packet to see if the destination IP address is on the local area network. Okay, do I need to send this out on the internet, or is this actually another computer that's connected here to my local network? So if it's not on the local network, then the packet is sent to the internet, to the wide area network through the sender's ISP. This happens at the network layer. So network layer's got a lot going on. It's checking to see, is this on my network or do I need to send it out? So each data packet is sent from the sender's ISP to the destination ISP with the connected routers. The path each packet takes can be different in order to maximize efficiency and avoid bottlenecks. So we hadn't thought about that. If it sends it out on the network, there's lots of different networks out there, and it may break up the pieces and send them on different routes to get there just for the speed, because this network may have a whole lot going on, so it'll break it up and put it on different networks. Packet switching. Packets each take different paths, so when they arrive at the destination in the wrong order, because some networks will be quicker than others. So the packets are then unpackaged and reassembled into the original binary data based on the sequence number. Oh, this is number 3. Let me hold on to that. I don't have number 1 and number 2 yet. Okay. Oh, here's number 1. All right, waiting on 2. It puts it together. And if any packets are missing, a message is sent back to the sender asking for the packets to be sent again. So the computer will do all that behind the scenes. Hey, I never got packet number 2, and it'll resend that real quick. So it's all happening in milliseconds a lot of times. So it makes packet switching a very reliable system. So it's got all those built-in checks in there. All right. Interesting stuff here. What's your address? So millions of the people in a nation means millions of devices on the internet. I mean, we got like 370 million people in the US, and a lot of them have computers. And a lot of them have more than one computer. They have a computer at work. They have a computer at home. They have your phone is a computer nowadays and has the IP address. And just as people are identified by their social security numbers and their home address, every computer must have its own address. Every communication device. Every network device has a physical address. This is called a MAC address, and it's assigned at the factory. Then when you buy a network interface card to install a computer, the MAC address is fixed and can't be changed. That is that computer's address there. But what if you want to use some other addressing scheme to refer to the computers or other devices in your network? This is where logical addressing comes in. It lets you access a network device by using an address you assign. So logical addresses are created and used by protocols like the IP or the IPX. So the OSI network layer protocol translates logical addresses to MAC addresses. Like when you get a computer, you'll see a physical address, which is the MAC address, like this F5-8F-38-D9. Oh, that's assigned to the computer. It's the only one like it anywhere, right? Because that is just for that computer. But the IP address will be assigned when you hook up to a network, 192.168.1.35. And if you take it off this network and you install the computer on another network, the IP address will change, because that's assigned by each network, the IP address. So this probably has 34 other devices attached because it assigned this as 1.35. There's a 1.34 out there and a 1.33. The IP address is different than the MAC address. So the bottom line, here we go. A lot goes on behind the scenes when a user connects to a network. The OSI model is a tool used to understand, diagnose, and resolve issues when a device can't connect or files are not sending. So protocols are the set of rules that control the communications between computers, and these same protocols reside on different layers of the OSI model. So packets are sent over the network to the sender's IP address, and together all these things make it possible to get and stay connected on networks large and small. So that's the end of our lesson there. A lot about networking this week. You got the assignment there where we've got just some questions this week. You got 3 attempts on that. 1, 2, 3, 4, 5 questions just about all of this networking stuff that we've talked about. So there you go. A lot of good stuff. If you get into cybersecurity, you definitely need to know all the layers of how everything works so you can see when there's a problem, you know, what to look at and try to figure out what went wrong with everything. So, all right, guys, that's it. I won't keep you any longer. We looked at some interesting stuff there. Don't forget it's Fat Bear Week. Vote today, vote tomorrow. It'll be over then. But we'll see you guys next time. No Friday this week. Fall break. Next week, no, let me talk about that real quick. Next week, we don't have Monday because it's fall break. Wednesday is PSAT work keys. We're not going to have class on Wednesday. We'll only have Friday. So what I plan on doing is I will just make a video and post it in Google Classroom, and we won't meet next week unless you got questions and want to come on Friday. But I won't have a planned Friday class since it's the end of the week. That work? All right, guys. Have a great week. Have a good fall break, too. See ya.